Hello to all, welcome to the channel Money's Gate Tech Vision. In this presentation, I am going to solve some gate problems on the topic of eigenvalues and eigenvectors from linear algebra in engineering mathematics. In the previous presentation, I have solved some gate problems on the topic of eigenvalues only. Here, in this presentation, I am going to solve gate problems to find the eigenvectors for the given matrix. Let me solve the problems. The first problem, this is one of the MSQ question given in the gate paper, multiple select question. This is one of the multiple select question given in the gate paper. First, I will read the problem. The matrix A equals 1, 2 cross 2 matrix is given, has eigenvalues -5 and 7. The eigenvector is R dash. So, there are 4 options given for the eigenvectors. We need to find 2 options. We need to find the options. Which options are the correct? Which are the eigenvectors correct for the eigenvalues -5 and 7? So this is one of the multiple select question. 2 or more will be the correct. So here I am going to solve the problem. There are only 2 eigenvectors for 2 eigenvalues. So there are two formulations. First formulation is A minus lambda I into x equal to 0, where lambda is the eigenvalue, given eigenvalue, I is the identity matrix, x is the eigenvector. So A minus, with this formulation we can find two equations. With the two equations we can find the eigenvector elements. Okay. Or other formulation is Ax equal to lambda x. Ax equal to lambda x. So with this two formulation, either we can use this formulation or we can use this formulation to find the eigenvectors for the corresponding eigenvalues -5 and 7. So here eigenvalues are given. So either we can use this formulation or we can use this formulation. So in this lecture, I am going to use this formulation only. I am going to use this formulation only, Ax equal to lambda x. So with this formulation, we can find the eigenvector for the given eigenvalues. So with this formulation, we can check with the options. I am going to check with the options only. A, B, C and D are given. So I am going to check one by one. I am going to check one by one. So for lambda equal to -5, two eigenvalues are given, -5 and 7. So let me substitute lambda equal to -5 in this formation. A is the given matrix. The matrix elements are 4, 3, 9, -2 into x is the eigenvector having the variables x1, x2 equal to -5 is the lambda into x1, x2 is the eigenvector. Okay, this is for lambda equal to -5. So if we put lambda equal to 7, another eigenvalue, the formation will be 4, 3, 9, -2 is the given matrix elements into x1, x2 is the eigenvector equal to 7 into x1, x2 is the eigenvector. So this is the formation for lambda equal to 7. So with this two formation, I am going to find the eigenvector. I am going to check with each options. First I am going for option A. Let me check with the option A. Option A is the eigenvector which is having the elements 1, 1. I am taking this for lambda equal to -5. So if you put lambda equal to -5 and x is the eigenvector which is having the elements 1, 1. So this is the option A eigenvector. I am substituting here. So I am going to check the left hand side elements and right hand side elements. So here 4 into 1 plus 3 into 1, 7. 9 into 1 minus 2. 9 minus 2 is 7. So left hand side elements are 7, 7. And right hand side elements are -5 into 1, -5. -5 into 1, -5. So left hand side elements and right hand side elements are not equalized. So this is not equal. This is not satisfied. This formulation Ax equal to lambda x is not satisfied for the eigenvalue lambda equal to -5. Let me check for the other eigenvalue for lambda equal to 7. So for lambda, if we put lambda equal to 7 for the option A eigenvector, 4, 3, 9, -2, 1, 1 is the eigenvector for the option A and 7 into 1, 1. So let me check with these values. 4 into 1 plus 3 into 1 is 7. 9 into 1 minus 2, that is 7 in the left hand side. And in right hand side, 7 into 1, 7 into 1, 7, 7. So here also 7, 7. Here also 7, 7. So left hand side elements and right hand side elements are equal. Or formulated, satisfied. So this Ax equal to lambda x formulation is satisfied for lambda equal to 7 for the eigenvector 1, 1 given in the option A. So option A is the correct one. Option A is the eigenvector for the eigenvalue lambda equal to 7. So here 2 cross 2 matrix is given. So there will be 2 eigenvectors. Already we found out one eigenvector which is having the elements 1, 1. Option A is the correct one. We found one option. We found one option, option A. And let me check with the option B. So already we found out for the eigenvalue lambda equal to 7. So then we can check with the option eigenvalue lambda equal to minus 5 only. So let me check with the eigenvalue lambda equal to minus 5. Let me check with the option B. 3, 4 are the elements. So for lambda equal to minus 5, in this formulation Ax equal to lambda x, this is A, and into x equal to minus 5 into x. So let me check with the left hand side elements and right hand side elements. So 4 into 3 plus 3 into 4, 12 plus 12 is 24. 9 into 3, 27, minus 8 is 19. And in right hand side, minus 5 into 3, minus 15, minus 5 into 4, minus 20. So, both the elements are not equal. Here, left hand side elements and right hand side elements are not equal. So, the formulation is not satisfied for option B. And option B is wrong. And let me check with the option C. 2 minus 6. Let me check with the option C for lambda equal to minus 5. Lambda equal to minus 5. I am substituting lambda equal to minus 5 and option C eigenvector. So let me check with the elements. 4 into 2, 8. 8 minus 18 is minus 10. And here 9 into 2, 18. 18 minus 2 minus 6 is 12. 18 plus 12 is 30. And here minus 5 into 2 minus 10. Minus 5 into minus 6 is 30. So here the two sides elements are equal. Left hand side elements are minus 10, 30. Right hand side elements are minus 10, 30. So the two side elements are equal and the formulation is satisfied for lambda equal to minus 5. So this is the eigenvector. Option C is the eigenvector for the lambda equal to minus 5. For eigenvalue lambda equal to minus 5. So we found two eigenvectors. One is option A, other one is option C. So this is the 2 cross 2 matrix. So already we found out two eigenvectors for minus 5 and for 7, 1, 1 is the eigenvector. For minus 5, 2, minus 6 are the eigenvector. So there will be no need to check for the option D. Already we found out two eigenvectors, option A and option C. So with this we can stop and we can conclude the answer as option A and C are the correct one. Let me solve another problem. This is also one of the MSQ question given in the gate paper, multiple select question given in the gate paper. I will read the problem. Which of the following is or are the eigenvectors for the matrix given below? This is one of the toughest question because this is a 4 cross 4 matrix given. There is no eigenvalues given. In the previous problem, minus 5 and 7 are given. That are the eigenvalues. With that eigenvalues, we solved for eigenvectors. Here, in this problem, they didn't give eigenvector and they didn't give eigenvalues also. We need to find the eigenvectors without the eigenvalues. So, here also we can use two formulations, A minus lambda A into x equal to 0 or Ax equal to lambda x. So here we are in the 4 cross 4 matrix. If we use this formulation, this will be toughest for you because there will be 4 equations. We need to solve for 4 equations. So that is very lengthiest process. So better not to select this formulation for this type of toughest question. This type of matrix 4 cross 4 or 3 cross 3 matrix. We can use this formulation itself. Okay, we can use this formulation itself. Ax equal to lambda x. We can use this formulation itself. So like the previous problem, we can check with the options itself. Okay, so let me check with the option A. So option A is the eigenvector having the elements minus 1, 1, 0, 1. So let me substitute A as a matrix element and into x is the option A eigenvector equal to lambda. We can keep as such into eigenvector. Now we are going to equate. So minus 9 into minus 1, minus 9 into minus 1, minus 6, minus 9 into minus 1, 9 minus 6, 3, 3 here minus 2 into 0, that can be discarded, and minus 4, minus 1 will be there. And here minus 8 into minus 1, that will become 8. 8 minus 6 is 2, and 2 minus 2 is 0. 2 minus 1 is 1. Okay, and then 20 minus 20 plus 15 minus 5, and then minus 5 plus 5 is 0, third element, and minus 32, last row, minus 32, because 32 into minus 1, the minus 32 plus 21, that will become 11, and 11 that will become minus 11, minus 11 plus 12, that will become 1, equal to lambda into the given eigenvector given in option A. So here, see this formulation. In the left hand side and right hand side, the same elements are there. Here also the same elements are there. If we put lambda equal to 1, the formulation Ax equal to lambda x is satisfied for the option A eigenvector. If you put lambda equal to 1, then the formulation is satisfied for the option A eigenvector. So with this we can find the eigenvalues also. So option A is the correct one for the eigenvalue lambda equal to 1. For the eigenvalue lambda equal to 1. So we can pick out for the option A first. Option A is the correct one. Okay. Let me go for the other options. Let me go for the other options because they didn't give the eigenvalues. Let me check with the option B. So option B is the eigenvector 1, 0, minus 1, 0. So in the, like this we are going to solve. 1, 0, minus 1, 0. So here minus 9 plus 2, that is minus 7. And here minus 8 into 1 plus 3, minus 5. And 20 into 1 is 20, and third element is minus 8. 20 minus 8 is 12. And 32 into 1, 32, and minus 7. 32 minus 7 is 25. So left hand side elements are minus 7, minus 5, 12, 25 equal to lambda into the given eigenvector given in option B. And here, if we put lambda equal to 7, let me check with the lambda equal to 7 means 7 into 1 is 7, and here also not satisfied. So for any lambda value, this formulation is not satisfied. This cannot be equated. This formulation is not satisfied. So we can conclude the option B is wrong one. So let me go for option C. Let me go for option C. Okay. So option A is the correct one. Already we ticked it. And let me check for the option C. Option C. So here option C are the elements minus 1, 0, 2, 2. Minus 1, 0, 2, 2 equal to lambda into the given eigenvector given in option C. And here we can find the elements minus 9 into minus 1, 9. And the third element is minus 2 into 2, minus 4. Minus 4 into 2, minus 8. The values are minus 3, 0, 6, 6 equal to lambda into minus 1, 0, 2, 2. So see, compare the elements in the left hand side and right hand side. If we put lambda equal to 3, lambda equal to 3 means 3 into minus 1 is, that will become minus 3. This can be equated. And then lambda equal to 0, lambda equal to 3 means, if you put lambda equal to 3, 3 into 2 is 6. And here also 3 into 2 is 6. So then the formulation is satisfied. Ax equal to lambda x is satisfied for lambda equal to 3. For the eigenvalue lambda equal to 3. So we can tick out for the option C also. We can tick out for the option C also. For the eigenvector lambda equal to 3. So let me check for the other option D. Other option D. Because this is a 4 cross 4 matrix, 4 eigenvalues are there. So already we found 2 only. There are 4 options only. With this, in this option B is the wrong one. Option A is the correct. Option C is the correct. And let me check out for the option D. Okay. So here 0, 1, minus 3, 0 are the elements in the option D. Let me check the elements. So here minus 6 plus 6 is 0. And here, and then minus 6, minus 6 and plus 9, that is 3. and then minus 9, 0 equal to lambda into 0, 1, minus 3, 0 are the this is the eigenvector given in option D. So let me compare the left hand side and right hand side elements. 0, 0, 3, 1, minus 9, minus 3. So here also if we put lambda equal to 3, 3 into 0 is 3, 3 into 1 is 3 are equal, and 3 into minus 3 is minus 9. So that will become the two elements will be equal for lambda equal to 3. So if you put lambda equal to 3 again, these elements will be equal. The right hand side elements and the left hand side elements, that will be equal, and the equation, the formulation will be satisfied for the option D. Option D is also the correct one for the eigenvalue lambda equal to 3. So there are two equal eigenvalues, lambda equal to 3, again lambda equal to 3 and lambda equal to 1. So lambda equal to 1. So with this option D is also the correct one. So we have found out for option D. So option D is also the correct one. So this is the option A, option C and option D are the correct options for the given matrix. So multiple select. Three options will be the correct one for the given question A, C and D. This is Mani's Gate Tech Vision. This is a channel for engineering competitive examination. You can subscribe to my channel. You can view the lecture series regularly. It will be helpful for the GATE examination and other competitive examinations. And thank you for watching the video.